Hello 8th class students. The next chapter which we are going to discuss is sound. It is a very easy and very simple chapter. There are very few topics in it which I am going to explain you. First was the videos related to sound which I am going to send you now in the continuation of this week. See, the chapter is very small, but in later on stages you will have a long continuation. So this is the foundation course which you will be getting in sound, so do watch it. Thank you.
Hello friends, this video on sound part 5 is brought to you by examfear.com. No more fear from exam. A lot of sounds. While we are talking, we are singing, shouting. So in all these cases, we are also producing a lot of sound. Now the question is, how are we producing sound? Because whatever we have understood so far is sounds are produced by vibration. So does that mean that something is vibrating even inside our body which is producing sound? Yes, of course, that has to be true in our case as well. So now the question is, what is vibrating inside our body? So let us quickly see how exactly sound produced in human beings. So in human beings, we have a specialized structure called the larynx, which is responsible for the production of sound, and that is why larynx is also known as the voice box. So larynx is called the voice box because it is responsible for producing sound. And where is larynx located? It is located inside our throat. So this portion, so if you look at, especially in case of males, adult males, if you look at the portion of their throat, you can see a protruded part of their throat. So that protruded part is nothing but larynx. So larynx is located in that part because in case of males especially, the larynx get enlarged as they enter into their mature ages. So that is why the larynx becomes visible from outside. But in case of females, larynx is not that clearly visible from outside. So this is where the larynx is located. So now we will try to understand what exactly the larynx does that help in production of sound. So larynx is called the voice box, as I said. Where is it located? It is located at the upper end of the trachea. What is trachea? Trachea is nothing but the windpipe. So what is that? Now whenever we breathe in, how do we breathe in? We breathe in through our nostrils. So air enters into our nostrils, it enters into the nasal cavity, and finally where does it go? It goes through the windpipe and it reaches the lungs. So here you can see these are the two lungs. So there is a pipe which carries the air which we have breathed in from our nostrils to the lungs. So this tube is called the windpipe or trachea. So here you can see this structure which you see here, that is trachea. It is a tube-like structure which connects to the lungs. Now, from where the trachea starts, this is where the trachea starts, and towards the upper end of the trachea is present the larynx. So this structure which you see here, this one, yes. So this structure is larynx. So it is just located at the upper end of the trachea, or you can say that the superior trachea or the upper end of the trachea specializes to form this voice box. Okay. So the location is clear. Now the question is, what is that special thing which is present inside this voice box that help in vibration or production of sound? So this is how the structure of the larynx looks like if you look through the throat from the top view. So if you look down from the throat of a person, you ask a person to open his or her mouth and then you try to look deep inside through his throat. So this is how it will look like. So here you will be able to see two cord-like structures present which are called the vocal cords. So here you see two cord-like structures. These are called the vocal cords, and these vocal cords actually are the vibrating part of the human body. So due to the vibration of these vocal cords, we are able to produce sound. Now what happens to these vocal cords? These vocal cords, they are located in such a way, here you have muscles which fix them from behind. So now due to the contraction and expansion of the muscles, these vocal cords, they can open and create some space in between them. Like here you can see there is an opening between the two vocal cords. Similarly, they can come closer and the opening can be closed. Now, when there is opening, what will happen? This opening will allow the air to flow in or out of the lungs. As I said, air will go through the nostrils, nasal cavity, and finally the air wants to reach the lungs through the trachea. So here, all that you see here, this portion shows you trachea. It actually goes to trachea. It is like a door. Now when the vocal cords come close together, like in this case, there is no opening. So in this case, the air cannot pass through freely into the lungs, or it cannot come out of the lungs because the door is closed here. But in this case, it is open. So when the vocal cords are open, and when are they open? They are open during normal breathing, because when we are breathing normally, that time, what do we want? We want the air to reach the lungs. So now this is the scenario in case of breathing. As I said, so during breathing, they remain, the vocal cords, they open up the space in between them. Now when this space is open, in that case what will happen? When we breathe, the air is allowed to flow in through this opening into the lungs as well as out of the lungs. Like when we breathe in or breathe out, so that air exchange has to happen. So this provides the path for the air to flow into the lungs as well as for the air to come out of the lungs. So this picture, the first scenario, is the case which happens during normal breathing. So during breathing, this is how the alignment of the vocal cords will be. Now what happens during talking? Now during breathing, the sound produced is very feeble. You do not hear the breathing sound that properly. But what happens during talking? So when you talk, you are actually producing a considerable amount of sound. So during this case, what happens is they remain closed. So when I say close, I mean the vocal cords, they are like very close to each other. So you do not have that space here to allow air to pass into the lungs. So what will happen in this case? In this case, the vibration of the air can be felt from outside during talking. Like when you are talking, just try to touch your larynx from outside. Just try to touch this part of your throat when you are talking, and you will be able to feel the vibration with your fingers, because during this case, when they close, a pressure develops in the lungs, because now the air is not able to come out, or it is not able to come in freely. So a pressure develops in the lungs which initiate the vibration of air flow between the vocal folds. So here the vibration of air takes place, like how in case of a flute there is vibration of air column taking place inside the tube. In a very similar way, here also, due to the closure of the vocal cords, there is a pressure which develops from the lungs, and as a result, when the air tries to come to the larynx, it reaches that surface and it sees that the gates are closed. So what will happen? Like it is something like this. Let us say you go to a movie theater and there is a rush of say 500 people who wants to enter inside the theater. Now suddenly the door gets closed. So what will happen? Everybody is trying to move inside the hall and suddenly the door got closed. So the pressure will develop. In a very similar way here also, pressure develops, and as a result, vibration of air starts. And due to this vibration of air, sound is produced. So this is how the process of sound production takes place in case of human beings. So which part of our body is responsible for voice production? It is larynx. And what part inside the larynx is responsible for the vibration? It is the vocal cords, because due to the alignment of the vocal cords only, the air vibration gets initiated. So with this, we have discussed the various ways, the cause of sound production, how sound is produced in various musical instruments, in case of human beings, in case of all other sounds which we see around us. So the production of sound part is clear now. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 6 is brought to you by examfear.com. No more fear from exam. So by now we know that sound is produced by vibration. So that is clear. Now the question is, how does sound propagate? What do we mean by propagate or propagation? The term propagate refers to spreading something. That means to spread or to get transmitted. So how exactly do you think that sound is getting transmitted from one place to another? Now, first of all, do you think that sound is getting transferred from one place to another? Just look at this example. When you talk to somebody, okay, so let us say you are in a conference room, you are in a meeting where some 10 people are sitting there. Now, when one person speaks, all the other people are able to listen to it. So that means the sound produced by one person, let us say this person is speaking. So the sound produced by this speaker is produced by the larynx of the speaker, but that means that this sound is traveling in some way so that it is able to reach the ears of the listeners. That is why they are able to hear it. That means sound is traveling in some way. So the question is, how does sound propagate? Now, it is not only that only when you are present nearby you are able to hear each other. Sound is also able to get transmitted over long distances. For example, when an aeroplane is flying high in the sky, you are able to hear that noise of the aeroplane. Right? Similarly, if there is a train which is quite kilometers away from you, but still you are able to listen to the whistle of the train. So have you noticed that these kind of sounds which are produced by one source is heard by quite a number of other people? That means it is able to get transmitted over distance. So now the question is, how is sound traveling from one place to another? So sound always needs a medium for propagation. That means it needs some medium through which it can travel. Now, you might ask, now what is this medium? So let us try to understand the meaning of medium. So what it is trying to tell is, let us say, look at this scenario where these two persons, they are talking to each other. So now when this person speaks, the sound is actually getting transmitted up to this person. Similarly, when he speaks, the sound is getting transmitted till here. The question is, does sound need something to travel from person 1 to person 2? Yes, sound needs a medium. So let us see what is a medium. Now, first let me give you some example so that you know what is medium. Now, when you think of these vehicles on the road, you have a car or you have a bicycle, you have a scooter, you have a bike. So any sort of vehicle, how will the vehicle run? So where will you drive your car? You need a medium, right? So your car cannot fly in the sky. Your car needs a road. So it can only travel on road. So the road is the medium on which your car can travel. Now let us take the example of a ship or a boat. So do you think that it can just fly on its own, or it can by itself it can move from one place to another? No, it again needs a medium. So what is the medium for this boat or this ship to travel from one place to another? Medium is the water. So water is the medium here. If you think of an aeroplane, what is the medium for an aeroplane? Where can the aeroplane move from one place to another? It needs a medium, and the medium is air. So now are you able to understand what is the meaning of medium? Medium means, you can say, it is like a base on which a particular object can move from one place to another. So in a very similar way, like how you have the car or the aeroplane or the ship here, similarly sound also wants to travel from one place to another, and for that this also needs a medium. So what is the medium for sound? What kind of medium does a sound needs? It needs water, air, or what does it need? So that is what we will see here. So how can we define medium? Medium is nothing but an object through which sound is transmitted. So what could be this object? Now, this object can be a solid, the object can be a liquid, the object can even be gas. That means sound can travel through air, sound can travel through liquids like water, sound can also travel through solids like wood or metals, right? So, and all these objects through which sound gets transmitted, these objects are called as medium, right? Okay. So, as I said, the medium could be a solid, liquid or gas, but a medium is required. So, something has to be there. Now, you might ask, what do you mean by medium has to be there? So, obviously, everywhere there will be either air or water or some other substance, so something will always be there. But that is not the case. We can even create an atmosphere or an environment which is completely empty, which doesn't even have air, nothing is there, and that is known as vacuum. So sound cannot travel in vacuum. So we will now quickly talk about vacuum as well. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 7 is brought to you by examfear.com. No more fear from exam. Sound can never travel through vacuum, and vacuum means complete empty. It has nothing. Nothing means absolutely nothing. Many of you might be getting to know this term vacuum for the first time. So let us try to understand what is vacuum. It is a space which is completely devoid of matter. Please remember, it is completely devoid of matter. Matter means anything that occupies space is matter. Solid, liquid, gas, everything falls under matter. Now let me give you a very simple example to explain what do we mean by vacuum. Let us suppose you have a bottle, and this bottle is filled with water, right? So will you say that the bottle is empty? No, because the bottle is already filled with water. So right now, what do you have inside the bottle? You have liquid inside the bottle. Now what do? You take out the water which is present inside the bottle. So you have taken it out. So now, will you say that the bottle is empty? Yes, many of us would say that yes, the bottle is empty because there is no water inside the bottle. But if I ask you, is there anything present or is there matter present inside the bottle? Yes, of course, because air is present inside the bottle. The moment air is present everywhere around us, right? So the moment you take out or you pour out the liquid from the bottle, so even before you can put the cap on the bottle, air enters inside. So air is sitting inside the bottle. So now also the bottle has matter. Now, there are techniques by which you can take out even the air from the bottle. And then what do you say? The bottle is completely devoid of matter because now it doesn't contain any liquid, any gas, nothing is there. And then we say that a vacuum has been created inside the bottle. Right? So that is vacuum. So vacuum means absolutely nothing, no matter at all. Now, you might be thinking that it might sound to be little, little imaginary for you that something like vacuum also exists, or how do we create vacuum? Now, as you go to your senior classes, you will learn about the various methods by which you can create partial vacuum or you can create vacuum. So I will not get into those details right now, but yes, it is not an imaginary concept. Yes, it is possible to create vacuum. You can actually create emptiness, complete emptiness inside an object. So I will give you some of the examples which you see around yourself where you can feel vacuum to some extent. So one such example is a magic. which is often shown to kids, but it is not actually a magic, but a simple scientific phenomenon. All you need to do is take a glass, fill it with water up to the top. So completely fill it with water. Now you place a paper card over it. Okay, sounds simple? Now as soon as you place the paper card over it, you quickly turn it upside down, like how it is done in this picture. So now this glass is completely filled with water and this is the paper card. Now as soon as you turn it upside down, what do you expect to happen? Normally what we expect is that the paper card should fall down and the water inside the glass should also fall down. That is what we expect. But you will see a magic. What happens is, even when you turn it upside down, the paper card sticks to the glass. So it is like a magic. The glass is turned upside down, but the entire water is there inside the glass and the paper card is also sticking to it. So many magicians show this as a magic, but there is actually a very simple science behind it. What happens is, a low pressure area or partial vacuum is created, and due to the creation of this partial vacuum, and where is this partial vacuum created? Now, normally why do we expect that the paper card will fall? Because the water which is present inside, this weight of the water will push the paper card downwards, and that is why the paper card will fall and the water will also fall. That is our expectation. But what happens is, just between these two layers, like you have water here and this is the paper card, just between these two, a very thin layer of vacuum is created. Vacuum means where there is nothing, no air, no water, nothing. So this vacuum acts as a separation between the water and the paper card. So the water is not able to push the paper card, and that is why the paper card is not falling down. So that is the simple logic. So here you see the role of vacuum. So here partial vacuum is created. Another example where you can see partial vacuum is the suction caps. Have you ever seen these kind of caps? So I'm sure you would have seen it. I mean, you often use it for hanging stuff. So they also have these kind of suction caps. And what happens to them? When you stick them to a smooth surface, they get stuck very tight, and then it becomes very difficult to bring them out. So why are these caps being able to stick to a smooth surface so tightly? That is also due to the creation of vacuum. So the space inside this, so this inside space, it has vacuum. So there is no air inside. So it becomes airtight. So you would have heard the term airtight quite often. These days, there are so many containers which they say that they are airtight containers. So if you keep food materials inside that, so air will not be able to enter, and that's how they will not get spoiled and all. So basically vacuum, I hope you would have understood by now what is vacuum. Okay, so now what we were talking about was the propagation of sound. So now if sound wants to travel from one place to another, it needs a medium, and it cannot travel in vacuum. So these were the two important conclusions. Now, one very popular experiment, which is known as the bell jar experiment. So this experiment showed that sound cannot travel in vacuum. Now, when I say that sound cannot travel in vacuum, what I mean is, so if there is a sound being produced from some source, other people will not be able to hear it if it is all vacuum, because sound will not be able to get transmitted from the source to the listeners. So here in this apparatus, so here you can see this is a bell jar. So this is the jar, as you can see, and this jar is connected to a vacuum pump. So the purpose of this pump is to create vacuum inside. How will it create vacuum inside? By taking out all the air from the bell jar. So here inside you have vacuum. That means it is devoid of matter. Nothing is there inside. And inside this you have this electronic bell. And the switch of this electronic bell is somewhere here, as you can see here. So now what do you normally expect? If you switch it on, the bell should ring. right? And in normal situation, what happens? When your doorbell rings, you are able to hear the sound of the bell. Why? Because sound can travel through air, and air is present around you in your house. But in this case, when you switch it on, the bell rings, but you are not able to hear it because it is all vacuum inside. So the sound is not able to travel from, this is the source of the sound. So the sound is not able to travel from here. And that is why nobody is able to hear the sound of the bell. So this is a very popular experiment which proved that sound cannot travel through vacuum. And therefore sound needs a medium to propagate. And this medium could be a solid, it could be a liquid, or it could be a gas. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 8 is brought to you by examfear.com. No more fear from exam. So now let us talk about solids. Let us see, or let us try to prove that sound can travel through solids. In fact, you can also prove these small things yourself. So let us take some examples of solids and we will see that how sound can propagate through them. So the first example that we can take is that of this wooden table. So this is wood. So wood is a solid, right? So here you see there are two guys. Now this guy, what is he doing is he is beating the table. So he is striking on the table. So that is producing some sound. Correct? Okay. Now this sound is being heard by this person who is like, now he is not beating it very hard so that everybody can hear it. Like even if he is very gently tapping the table or he is scratching the table, and if somebody else who is on the extreme other end of the table and he keeps his ears close to the table, he would be able to hear the sound which is being made by first guy. So that is because, why is he able to hear this? Because sound can travel through solids. Now, if you want, you can try some other experiments also. For example, instead of using a wooden table, you might use a metal rod. So you use a metal rod and which is not hollow, it is like a solid rod, and somebody is making some sound on one end and you keep your ear on the other end and you will be able to hear the sound. So basically sound can travel through solids like metals or wood or strings, plastics, etc. So let us look at these examples. Like when you talk, you would have created the toy telephones when you were kids. Like you just take two boxes and then you attach them with a string and then you talk to each other. So how are you able to talk to each other? Because sound can travel through solids. Now when I say that sound can travel through solids, some of you might even think that, but I have heard people saying that there are certain substances which are very good in absorbing sound. So some of the solid materials also act as sound absorbers. So if we use those materials, sound gets reduced. One such example is curtains. You would have seen that if you have curtains in your house, the sound transfer reduces. Or let us say if you are sitting inside your study room and you are speaking something loudly. Now when the door of your study room is open, then your sound is reaching more to your living room. But when the door of your study room is closed, your sound is reaching less to the living room. Why? Because when the door is closed, or when you have things which are good sound absorbers like curtains or fiberglass or foam, etc. So these materials, they tend to absorb sound energy. So when they absorb, so less amount of sound energy is being transmitted further. So therefore you would have seen that in offices, the conference rooms or the recording rooms, they are all made soundproof, so that sound from outside cannot enter inside the room, and similarly sound from inside cannot come outside the room. But otherwise, when you talk about propagation of sound, sound can propagate through solids, whether it is metal, whether it is a wood, whether it is a string, whether it is a plastic. Sound can travel through them. And another important thing is, it is not only that it can travel, and it can also travel in all direction. It is not that it can only travel in one direction or it will travel only linearly, nothing like that. It just travels in all direction. Now we will take the same example. Now this guy is beating the table or striking the table. So the source of sound is here. This person is able to hear the sound from here. Now let us suppose if somebody is standing here, do you think he will also be able to hear the sound? Yes, of course. If somebody is standing just next to him here, will he be able to hear the sound? Yes, of course. That is because the sound travels in all direction from the source. It is not that it will travel only in one direction. Okay, so this was about propagation of sound through solids. Now let us talk about liquids. How sound travels through liquids. So now, in order to check the propagation of sound through liquids, you can perform this very simple experiment. What you can do is, you take any vessel containing water and fill water to the surface. Now, take a bell deep inside the water. So as you can see here, so the bell is completely under the water, and then you ring the bell. You just move it, so it should ring. Now, if sound travels through water, you should be able to hear the sound when you are at the surface of the water. Now, what do you see? You see that yes, you are able to hear the sound of the bell. So that proves that sound travels through liquids. In fact, this is how the aquatic organisms, they speak with each other. So if you look at the oceans, not only oceans, if you look at a small aquarium, you see a lot of living organisms inside that aquarium. Like you see a lot of different fishes, you also see small creatures. And what do you think? How do they communicate? So they also communicate with some sort of sound. And they are able to communicate with the help of sound because sound can propagate through water. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 9 is brought to you by examfear.com. No more fear from exam. Now we saw that sound travels both through solids as well as liquids. But where do sound travel faster? Now is it something like, is it dependent, the speed of sound, is it dependent on the type of medium through which it is propagating? Yes, of course. It depends, and that is why it is seen that sound travels faster in solids than in liquids. So that means if sound has to travel through something like a wood or a metal, it will travel faster when compared to a liquid like water. Now you might be curious to know why is there a difference in the speed of sound in solids and in liquids. So let us see how exactly sound propagates. Now whenever we say that the sound is propagating, that is, sound is nothing but a wave, right? So this wave is like a disturbance which makes the particles of the medium to vibrate. So here if you see, this is a source of sound. This is maybe a speaker or something from which sound is being produced. And this is your ear which listens to that sound. So that means the sound is traveling from source to the human ear. So now when it travels, how it travels? It is nothing but it needs a medium so that the particles of the medium can vibrate. Now here what is the medium? Nothing but air. Now air contains a lot of tiny particles. Now these particles start vibrating. So here you see the black dots. They represent the particles of the medium, that is particles of the air. Now just try to look at this overall picture. What do you feel? You feel as if things are moving in this direction. That is what you feel, right? When you look at the overall picture, right? Now, what you try to do is just try to observe the movement of one dot. So what do you see? How is this one particular dot moving? It is just vibrating about its mean position like this. That's how it is moving. Just try to observe some other dot, any dot of your choice. Just try to observe one particular dot, and again you will see that it is nothing but it is just moving like this. It is just a to and fro motion. So basically, when you observe it minutely, you will see that all the particles of the medium, they are just vibrating. They are doing nothing else. They are just vibrating and they are transferring the energy to the neighboring particles, and that is how sound is propagating from one place to another. So this is how sound propagates in simple words. Now, when I talk about solids and when I talk about liquids, how do they differ? So that's what we have to see. Now here, looking at this, you will see that at certain regions it is quite dense. There are too many particles. Again, for some region, less particle. Again, dense. So somewhere it is dense, somewhere it is less dense, right? You see these lines, wherever you can see, they are like more dense areas where there are more particles. So based on that, if you plot a graph, this is how you will get. You'll get crest and troughs, and that is how you define the wave nature of sound. So that is one thing. We will not get into all those details. So I hope you understood how sound is propagating. Now let us look at the scenario of a solid and a liquid. Now whenever you talk about a solid, in a solid, the particles are more. The particles are closely packed. So the intermolecular space is less. So you see more closely packed arrangement in solids. Whereas in case of liquid, the gaps are more, the intermolecular spaces are more. So in liquid, it is lesser. So in case of solid, since the number of particles are more, so the chances of one particle hitting a neighboring particle is also more. Therefore, the propagation is going to be faster because the propagation of sound happens with the help of vibration of each particle of the medium. So if the medium is a solid, that means there are more particles present. More particles, more vibration, more transfer of energy. So faster propagation. So that is why sound travels faster in solids when compared to liquids. Again, if you look at the way it is getting propagated. So this concept will remain the same whether it is solid or liquid. It is just that the speed of sound, the speed of propagation will change. Now let's talk about gases. So what do you say? Sound travel through gases? Yes, of course. Had it not been traveling through gases, we would have not been able to hear each other's statements. That's because when we talk to each other, the medium which is present around us is nothing but air. So in air, the sound is able to travel. Speed of sound through air is approximately 330 meters per second. That is the approximate value for speed of sound through air. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.